2017. A shard of rock named ʻOumuamua slipped past us, silent and alien, reminding us that the universe is never still. 2018. A quiet year in the sky, yet astronomers kept watching, waiting for the next surprise. 2019. Borisov followed, a true comet this time, trailing dust and chemicals that made astronomers uneasy. 2025. Atlas arrived, and it was different. Not just passing, not just drifting, but slowing, aligning, staying close. 3 interstellar visitors in less than a decade. If these were accidents, then history is coincidence. But if there is a pattern, a rhythm beneath the noise, then the question is no longer if another will come. It is when. Autumn 2025. Inside a dim room, a group of professional remote viewers, trained in methods once tested by the CIA and Stanford, were given nothing but coordinates. No hints, no context. The sketches they produced shook the air with dread. One saw antenna-like forms, eerily similar to ancient cave petroglyphs carved long before telescopes existed. Another described tunnels of consciousness, wormholes that bend space and thought. When the blind target was revealed, the room fell silent. Comet Atlas. Science calls it ice and stone, but the data tell another story. Strange deceleration near Jupiter, impossible gas ratios, alignments too precise to be chance. These aren't passengers of the void. They may be signals, markers, or the seeds of something larger. And so the heaviest question presses on us tonight. When will 4i arrive? Will it be the final accident of nature? Or the first deliberate arrival of something waiting in the dark? Turn down the lights. Slow your breathing. Because tonight we follow the trail from 1i to 2i to 3i. And we stare into the future, asking whether the next visitor is already on its way. For most of human history, the night sky was thought to be constant, a vault of stars fixed in their places, a stage where planets traced predictable arcs and comets swept across at rare but familiar intervals. Our ancestors carved those motions into myths. A comet might foretell the death of a king, or the birth of a new age, but it was never thought of as a visitor from beyond. It belonged somehow to our sky. That illusion shattered in October 2017. A small, elongated object came slicing into our solar system, on a trajectory unlike anything ever recorded. Its orbit was hyperbolic, meaning it wasn't bound to the sun. It wasn't circling back like Halley's Comet, nor falling in from the Oort cloud like the icy fragments that sometimes light up our skies. No, this was different. This object, later named ʻOumuamua, had come from interstellar space. It was the first time humanity could say with certainty, something from another star system has entered our own. At first, astronomers thought it was just a rock, a shard flung away from a distant world eons ago. But then the details emerged. Its shape was strange, cigar-like, or perhaps disc-like, depending on how it spun, unlike any comet we had catalogued. Even stranger, it showed signs of acceleration, a tiny but measurable push, as though it was being propelled by something other than gravity. Radiation pressure, sublimating gases, or something we had not yet considered. The debate raged. Was ʻOumuamua a natural fragment, or a messenger? 2 years later, in August 2019, before the mystery had cooled, another arrival shook the scientific world. This time it was a true comet, with a tail and chemical signatures that marked it as an interstellar traveller. 2i Borisov, discovered by an amateur astronomer in Crimea, confirmed what we had only dared to whisper after ʻOumuamua. Interstellar visitors are not once-in-a-civilization events. They come, they pass, and they leave traces. But then came 2025, and with it, something different. 3. Atlas. Larger. Stranger. Unlike Borisov's cometary consistency, or ʻOumuamua's silent ambiguity, Atlas bent the rules. Its chemical ratios were wrong, an 8.1 dominance of carbon dioxide that seemed too precise to be accidental. Its trajectory hinted at intent, alignments with planetary orbits that looked less like random arcs of nature, and more like deliberate navigation. And most disturbing of all, as it swept past Jupiter, it slowed. Interstellar objects don't slow down. They either fall into the sun or they leave forever. Atlas was not obeying those rules. Now, astronomers could have dismissed one anomaly. Even two might have been tolerated as coincidence. But three, arriving in such close succession, forced a question too large to ignore. Is this a pattern? 3 interstellar visitors in less than a decade, after millennia in which we recorded none. If these events are truly random, then we have lived through one of the most improbable coincidences in astronomical history. But if there is a rhythm, if the universe sends travellers our way in cycles, or if something beyond our star has taken notice of us, then ʻOumuamua, Borisov and Atlas may not be the end of the story, they may be the beginning. And so, even as telescopes track the last shimmer of Atlas, a heavier silence descends across the scientific community. The question is no longer, what was it? The question is what comes next. Somewhere, perhaps already inbound, is 4I, another interstellar traveller, another anomaly, another challenge to the fragile comfort that our skies are quiet and our solar system is our own. The future may be counting down already. We just don't know when the clock started. Astronomy is built on patience. Comets, eclipses, alignments. They arrive slowly, sometimes separated by centuries, and our job is to wait, to watch, and to record. Which is why the clustering of ʻOumuamua, Borisov and Atlas is so unsettling. Statistically, the odds of 3 interstellar bodies wandering through our system in less than a decade should be astronomically small. And yet, here we are. Some scientists argue that our instruments simply weren't sensitive enough in the past, that these travellers have always passed by, unnoticed, and that our new generation of wide-field telescopes has finally pulled them into the light. It is true. The Pan-STARRS survey in Hawaii caught ʻOumuamua, an amateur's telescope spotted Borisov, and the Atlas system flagged 3I. Each was a triumph of technology. But if detection is the only explanation, then the night sky should now be overflowing with interstellar wanderers. So far it isn't. Which means that, even with our modern eyes, each of these arrivals remains rare enough to sting with the weight of purpose. Cultures across time prepared us for this feeling. Ancient Chinese records describe guest stars appearing suddenly, burning with intensity then vanishing forever. The Babylonians tracked fiery omens across their clay tablets. Even the Maya spoke of cycles where the gods sent stones that breathe fire to reset human ages. Were these just poetic descriptions of ordinary comets, or echoes of something stranger? Humanity has always sensed that the universe sometimes sends messengers, and now the messengers are back. First, ʻOumuamua, sliding silently like a shard of alien glass. Then Borisov, trailing the unmistakable chemistry of foreign ices. Then Atlas, not behaving like a comet at all, but as something that tested our definitions of natural. Each one escalated the tension, from curiosity to confirmation to alarm. Which leaves us with the question scientists don't want to voice too loudly. If there was a first, a second, and a third, then what about the fourth? Astronomical naming conventions already have a placeholder for it. We call it simply 4I, the designation that will belong to the next confirmed interstellar object. But that name carries more than technical weight. It carries expectation. Because after Atlas, we cannot look at the sky with naive eyes. If another body comes, every observatory on Earth will tighten like a drawn bowstring, asking, does it drift or does it steer? Does it pass or does it remain? When will 4I arrive is not just the title of a study or a forecast. It is the question at the edge of our species' imagination, and depending on the answer, it may mark the beginning of humanity's greatest scientific revelation, or the opening chapter of a story that we are not prepared to read. If the universe has rhythms, then interstellar visitors may be one of its faintest but most consequential beats. For centuries, astronomers believed that comets bound to the sun were the only wanderers that touched our skies. Their periodic returns, Halley's every 76 years, Encke's every 3.3, gave us the comfort of predictability. But interstellar objects belong to no such calendar. They are drifters, unbound by the sun's gravity, each one cutting through our solar system on paths that will never return. So when ʻOumuamua appeared in 2017, it seemed like a once-in-a-millennium fluke. Estimates at the time suggested that perhaps only one such object would enter the inner solar system every 10,000 years. But then 2I Borisov arrived in 2019, just 2 years later. Suddenly the numbers didn't add up. Were we catastrophically wrong about the density of interstellar debris, or was something else at play? By 2020, a new wave of models emerged. Some suggested that the Milky Way might contain trillions of such fragments, relics from planetary systems torn apart during their violent births. These shards, ice, rock, or perhaps something less familiar, drift in vast rivers through the galactic disk. If Earth happens to be moving through one of these rivers now, then 4I is not a question of if, but when. And then came 3 by Atlas. Unlike Borisov's classic cometary chemistry, Atlas raised eyebrows. Its ratios of carbon dioxide and unusual outgassing triggered debates. Was this natural or engineered? Either way, its presence reinforced a new pattern. 3 visitors in less than a decade. That's not an accident. That's a clock ticking. But what kind of clock? Is it a natural cycle, like Earth's annual meteor showers, debris streams we pass through on schedule? Or is it a cosmic algorithm, deliberate in its pacing, one arrival following another as if in sequence? If 4I is next, its arrival could fall not in centuries but within years. Some projections argue it could already be inbound, dim and undetected, hidden in the solar glare or beyond Jupiter's orbit. The uncomfortable truth is this: the statistical models no longer point toward rarity. They point toward inevitability. The question, then, is not whether 4I will come, but whether we will recognize it when it does. Numbers have a way of stripping away illusions. When ʻOumuamua was first spotted, probability curves suggested we might wait thousands of years before another interstellar traveller appeared. But then 2I Borisov shattered those models. And with 3 Atlas, the statistical ceiling collapsed entirely. The math has flipped from rare anomaly to frequent inevitability. Today, researchers estimate that at any given moment, tens of thousands of interstellar objects larger than 100 meters could be moving through the solar system. Most are invisible to our telescopes, too dim, too distant, or masked by the sun's glare. The lesson: our view is not complete. We've only just begun to scratch the surface of a far denser cosmic traffic pattern than we dared to imagine. But probability doesn't just point to presence, it points to timing. If we plot the intervals between the first 3 confirmed visitors, a disturbing cadence emerges: 2017, 2019, 2025. The spacing is tightening. The line slopes toward acceleration. It is as if we've stepped into a corridor of encounters, a stretch of galactic space rich in wanderers. That means 4I might not be decades away. It might already be inbound, hidden behind Jupiter's bulk, or slipping through the dust-thick lanes near the ecliptic where our instruments falter. For governments, this isn't an abstract curiosity. An object approaching at interstellar speeds doesn't just raise scientific questions, it forces security questions. What if 4I carries unfamiliar chemistry like Atlas? What if its trajectory seems less random, more deliberate? Quietly, observatories have been instructed to scan more aggressively, pouring resources into all-sky surveys designed to catch fast movers. The Vera Rubin Observatory in Chile, once simply a tool for studying the dark universe, now doubles as humanity's first early warning net for the next interstellar arrival. Still, models leave gaps. Even with advanced statistical predictions, we cannot pinpoint when or where 4I will announce itself. It could flash into view tomorrow, tumbling past Neptune before we've had time to prepare. Or it could arrive 5 years from now, perfectly timed to stoke a planet already drowning in geopolitical tension and existential unease. The real terror of probability is not in its numbers, but in its silence. Because if 4I follows the accelerating pattern, if the cadence is real, not random, then humanity is not just watching the universe. The universe is approaching us, and this time we may not get to call it a visitor at all. We may have to call it neighbour. Every interstellar object has an origin story. ʻOumuamua, Borisov, Atlas. They were not created in our system. They were flung here, exiles of distant suns. To understand when 4I might arrive, we must first understand where it could come from. Astronomers speak of cosmic rivers, vast gravitational streams flowing through the galaxy. These are not literal rivers of water, but currents of stars, dust, and frozen bodies, remnants of galactic mergers and long-dead clusters. Some of these streams pass through the solar neighbourhood, carrying with them debris from billions of years of stellar violence. ʻOumuamua's trajectory, for instance, has been traced back not to a single star, but to the Carina and Columba associations, loose collections of young stars sharing motion. Borisov, with its unmistakable cometary tail, may have been birthed in a far older disk of a red dwarf, ejected when planets shifted in a chaotic migration. And 3I Atlas. Its strange chemistry suggests a nursery richer in carbon dioxide ice than anything we've seen locally, perhaps a star-forming region scarred by supernovae. If these origins seem remote, consider this. The Milky Way is laced with dozens of such rivers, each a conveyor belt of interstellar wanderers. The local interstellar cloud, the Hercules stream, the Hyaid supercluster, all are potential highways feeding our solar system with travellers, and Earth just happens to orbit in a crowded intersection of these galactic lanes. This means 4I's arrival is not a question of if, but from which direction, and when. The cadence of past visitors whispers that another is already riding the stream, invisible to us until it flashes against the sunlight. The terrifying truth: our solar system may be less like an isolated island and more like a busy harbour, with ships arriving long before we notice their sails. The question is not just where 4I originates, but whether we'll see it coming in time, and here the story grows unsettling. For all our advances, humanity's eyes on the sky are narrow. Most interstellar visitors are detected only after they've already passed perihelion, their closest swing to the sun. ʻOumuamua was spotted 40 days after it left. Borisov was found inbound, but so faint that only by luck did we catch its glowing coma early. Even Atlas, with its peculiar emissions, was discovered by a sky survey telescope designed to track near-Earth asteroids, not alien wanderers. The geometry conspires against us. Interstellar objects move fast, often slicing through the ecliptic at odd inclinations. They enter from directions close to the sun, hidden in the glare, or slip through blind spots where survey telescopes cannot stare. Some may pass unnoticed altogether, ghosting through the inner solar system while our instruments remain oblivious. And if the cadence of arrivals truly suggests another visitor soon, then 4I could already be here. Faint, small, undetected, lurking in the brightness of twilight skies. Astronomers warn of a detection paradox. The smaller and stranger the body, the more likely it carries exotic chemistry, yet the less chance we have of spotting it before it's gone. This means the first headlines about 4I might not read, "Object discovered inbound." They may read, "Object already departing." A haunting reminder that cosmic encounters are not always revealed in real time. The galaxy doesn't send invitations, it sends visitors, and sometimes they arrive before you even know the door is opened. If 4I is coming, then whether we recognize it depends entirely on the sentinels we've built around our planet. Humanity's defense against cosmic surprises is not armies or weapons. It is glass, silicon, and patience. Today, 3 great networks stand between us and ignorance. 1. The Pan-star system in Hawaii. It was Pan-stars that first caught sight of one ʻOumuamua in 2017, registering a faint moving streak against the background stars. Its giant digital cameras sweep the sky nightly, producing terabytes of imagery that software combs for anything shifting unnaturally. The telescope does not ask whether an object is natural or alien, it merely records. Its vigilance turned a fleeting speck into the first recognized visitor from interstellar space. 2. The Atlas Survey. Ironically named, given its role in this story, Atlas was designed as a planetary defense tool, to find dangerous asteroids before they found us. Its wide-field optics cover the entire night sky every 2 nights, scanning for anything new and fast-moving. It was Atlas that reported the 3rd interstellar visitor, 3I Atlas, in early 2025. Its discovery reminded us that what we call defense may also be a window into mysteries far beyond Earth's orbit. 3. The Vera C. Rubin Observatory. Soon, all of this will change. The Rubin Observatory in Chile, with its massive 8.4-meter mirror and 3.2 gigapixel camera, will begin an unprecedented project, photographing the entire southern sky every few nights for 10 years. Its Legacy Survey of Space and Time, LSST, is expected to catalogue tens of billions of objects, catching faint visitors that older systems would miss. If 4i exists, Rubin may be the first to see it, a sentinel powerful enough to transform chance discovery into predictable pattern. Yet, for all this technological triumph, a problem persists: the clock. Most interstellar wanderers move so fast that by the time we detect them, they're already inbound, already crossing the planetary orbits. Our telescopes are magnificent, but they are reactive, not proactive. This means that even with Rubin's sweeping gaze, the first announcement of 4i's arrival may still carry a familiar sting. We found it, but too late to watch it for long. For all our telescopes, all our vigilance, the truth is humbling. We are still nearly blind to most of the cosmos. Even the Rubin Observatory, with its breathtaking field of view, cannot see everything. Its surveys will focus on the southern hemisphere skies. Much of the north remains the domain of smaller, less sensitive telescopes. Clouds, weather, and seasons cut holes in our coverage. And then there's the sun itself, blinding our gaze toward half the sky at any given time. If 4i approaches from a sunward vector, we might not notice until it has already swept past Earth's orbit. There are deeper blind spots too. Most surveys are tuned to find bright, icy comets, not dark, rock-like bodies. ʻOumuamua was so dim it slipped past countless automated algorithms before being flagged. Imagine a visitor smaller still, or composed of material that reflects almost no sunlight. Such a traveller would be virtually invisible until it was already departing. Even when we do find them, the clock is merciless. Interstellar objects hurtle in at tens of kilometers per second. The detection to observation window might last weeks, sometimes only days. That is barely enough time to take spectra, let alone launch a probe. In essence, our current technology ensures that our first encounters are always fleeting, whispers of alien worlds that vanish before we can learn their stories. This limitation has forced astronomers to adopt a haunting perspective. Our skies are full of missed opportunities. We celebrate the few interstellar visitors we've confirmed, but for everyone detected, dozens, perhaps hundreds, have come and gone unseen. Which means that 4i may not be the fourth at all. It may be the 10th, the 20th, the 100th. The designation 4i could be a human illusion, a placeholder in a sequence we barely perceive. The true census of interstellar wanderers remains hidden, their paths crossing ours in silence. And so, when we ask, when will 4i arrive? The most unsettling answer is, perhaps it already has. Perhaps it's passing overhead tonight, unlit, untracked, a shadow drifting through the void, a reminder that our instruments reveal less than we imagine, and the universe owes us no warning. Astronomers do not like surprises. ʻOumuamua, Borisov, Atlas, each caught us unprepared, forcing hurried observations and frantic telescope scheduling. That frustration has given rise to a new science, predicting the unpredictable. At its core lies the principle of statistical inevitability. Our galaxy is not empty. It is littered with fragments of shattered worlds, rogue comets, and ejected asteroids. Planetary formation is violent, and stars fling debris into interstellar space with every close gravitational encounter. Multiply that by hundreds of billions of stars, and the Milky Way becomes a vast ocean of wanderers. Earth, orbiting quietly around the Sun, is a ship crossing this ocean. Encounters are not rare, they are certain. Mathematicians model these encounters using flux density equations, estimates of how many interstellar bodies pass through each cubic parsec of space, multiplied by Earth's sweeping orbital volume. The results are startling. Millions of such objects are passing through our solar system at any given moment, though most are too small or too dark to detect. But how many are large enough to catch? Based on early surveys, astronomers now expect a new detectable interstellar visitor every 1 to 5 years. That means 4i is not just possible, it is overdue. Yet prediction is not that simple. The universe adds layers of chaos. Some trajectories bend around Jupiter, masking a visitor's arrival until it slingshots past. Others emit faint comas only when warmed, making them invisible until they're already upon us. And still others may not reflect sunlight at all, forcing us to rely on infrared sensors that are only just now being deployed in orbit. To refine predictions, astronomers turn to the distribution of velocities. ʻOumuamua came from the direction of Lyra, Borisov from Cassiopeia, Atlas from Lynx. 3 random points on the star map, yet all hinting at a larger pattern. Most interstellar visitors drift into our system from the galactic plane, their orbits echoing the quiet river of stars that surrounds us. This suggests that when 4i does come, it too will emerge from that same corridor, the galactic highway of wanderers. For now, our models cannot name the date, the hour, or the object itself, but they can whisper probabilities, and those probabilities point towards something inevitable. The fourth is already on its way. If the math guarantees that 4i is coming, then the real question becomes, how soon will we know? The answer depends not just on physics, but on technology. Ground-based telescopes like Pan-STARRS and Rubin can only scan slices of the sky each night, relying on algorithms to catch the faintest moving dot among millions of stars. These systems are powerful, but they're limited by weather, daylight, and Earth's atmosphere. If 4i is dim or inbound from the direction of the sun, it could escape their gaze entirely. That's why astronomers are now turning to space-based surveyors. NASA's upcoming Near-Earth Object Surveyor will live beyond Earth's clouds and glare, staring into the infrared spectrum where even the darkest rocks glow faintly from their heat. With it, we could detect an interstellar visitor months, maybe years, before it brushes our skies. A warning time like that could transform science fiction into action. Robotic flybys, sample missions, even attempts to divert or capture fragments for study. But prediction also carries danger. What if we see too much? Detecting 4i early means grappling with implications long before the public is ready. Imagine confirming not just an inert rock, but an object with strange emissions, anomalous acceleration, or signatures we can't explain. The debates about ʻOumuamua and Atlas showed how quickly speculation spirals into panic. Governments may choose silence while independent scientists argue in the open. This is why AI has become central. Machine learning systems now sift through petabytes of nightly sky data, flagging oddities that human eyes might dismiss. Already, these AIs have discovered minor comets and asteroids weeks ahead of traditional methods. If 4i is coming, the odds are rising that a machine, not a human, will be the first to whisper its arrival. And that raises one more unsettling truth. We may not know exactly when 4i arrives until after it's already here. Predictions tell us it must come. Our instruments may tell us only that it has passed. The fourth interstellar messenger could appear tomorrow or 10 years from now. But when it does, the real test will be whether we are prepared to recognize it before it vanishes into history. Physics may predict the trajectory of stones, but it cannot predict the trajectory of human response. When we ask, when will 4i arrive, we're not just asking a technical question about orbital mechanics. We're also asking a cultural, political, and psychological question. What happens when humanity learns another visitor is inbound? The precedent is sobering. In 2017, the announcement of ʻOumuamua triggered a firestorm of headlines. Astronomers tried to remain cautious, but the public imagination leapt to alien ships, secret probes, cosmic messages. By the time 2i Borisov appeared, the narrative had shifted again. This was not anomaly, but pattern. Atlas only deepened that unease. Each discovery widened the gap between scientific caution and public fascination. Governments too have their own reflexes. NASA, ESA, and the Chinese National Space Administration all rush to reassure the public whenever an interstellar body is detected. They emphasize natural explanations, stress the harmlessness of the trajectory, and downplay speculation. Yet behind the scenes, resources are quietly reallocated. Missions are drafted, telescopes swing into position, silence and urgency go hand in hand. But perhaps the most volatile reaction comes from culture itself. Every interstellar visitor sparks waves of mythology. Some see messengers, omens, or even weapons. Others see opportunities, the chance to mine alien matter, to prove that life might travel between stars, to test our readiness for the unknown. Scientists measure light curves and spectra. Artists, writers, and conspiracy theorists measure possibility. And often, it is the latter that dominates public conversation. This is where the human factor becomes decisive. When 4i arrives, its meaning will not be settled by astronomers alone. It will be settled by how governments choose to frame it, how the media chooses to report it, and how billions of people choose to feel about it. Will it be cast as a harmless comet, a potential threat, or the harbinger of a new cosmic era. Each narrative carries consequences. Each could reshape our response. And lurking beneath all of this is the most dangerous possibility of all. What if 4i is different? If its trajectory, composition, or emissions cannot be explained away with the comfort of physics, then our response will be shaped not by science, but by fear. To understand how humanity might respond to 4i, we can look at the past, at the moments when the sky changed and people struggled to make sense of it. Case Study 1, Halley's Comet Panic, 1910. When Halley's Comet returned in 1910, newspapers warned that Earth would pass through its tail. Chemists discovered trace amounts of cyanogen gas there, and soon rumours spread that the planet would be poisoned. Gas masks, comet pills, and doomsday sermons swept across cities. Astronomers tried to calm the public, but fear proved stronger than fact. It didn't matter that the comet posed no threat. Perception alone created hysteria. Case Study 2, the UFO flaps of the Cold War. During the 1950s and 60s, sightings of strange lights surged across the United States and Europe. Governments, already locked in nuclear standoffs, grew paranoid. Some sightings were weather balloons, others classified aircraft, but many were simply misinterpretations. What mattered was not the truth of the phenomenon, but the climate of fear in which they were received. Even today, declassified files reveal that intelligence agencies worried more about mass panic than alien ships. Case Study 3, ʻOumuamua and the Debate of 2017. When ʻOumuamua was discovered, it was a scientific marvel, the first confirmed interstellar object, yet its strange acceleration and cigar-like shape created headlines proclaiming it a spaceship. Serious scientists like Avi Loeb lent cautious support to the idea of artificial origins, while others bristled. In the public sphere, nuance collapsed. Overnight, ʻOumuamua became a cultural Rorschach test. Proof of aliens to some, proof of cover-ups to others. These stories reveal a consistent pattern. The story told matters more than the data gathered. Humanity reacts first with myth, fear, or wonder, only later with sober science. When 4i arrives, whether tomorrow or 10 years from now, its reception will depend less on its orbit or spectrum, and more on the narrative we choose to wrap around it. Will governments downplay its significance? Will conspiracy communities amplify its mystery? Will scientists frame it as routine, or as the dawn of something extraordinary? The human factor is a magnifying glass. It can focus attention, sharpen curiosity, and inspire exploration. But it can also ignite paranoia, feed misinformation, and divide us. The fate of 4i's discovery may not hinge on what it is, but on who tells its story first. The human imagination has always tried to reach ahead of its time. When it comes to interstellar visitors, prediction is not just about telescopes and equations. It is also about how we envision the future itself. Computer simulations. Modern astronomy leans heavily on Monte Carlo simulations, running millions of hypothetical scenarios of how interstellar bodies might pass through the solar system. By tweaking velocity distributions, incoming vectors, and population densities, these simulations create probability maps, heat zones in the sky where the next 4i is most likely to appear. These are not prophecies, but statistical weather forecasts of the cosmic tide. Cultural futurism. Outside of science, thinkers have used futurism to imagine interstellar arrivals as transformative events. Writers and philosophers suggest that even a silent rock from beyond the stars forces us to confront questions of identity. Are we isolated? Are we being observed? Will interstellar debris one day carry not just stone, but life? This speculative current pushes scientists to look in new ways, to treat every interstellar body not just as data, but as potential message. Strategic forecasting governments also practice their own forecasting. Defense analysts quietly model scenarios in which the detection of 4i leads to economic panic, political instability, or new military initiatives in space. To them, 4i is not just a celestial object, it's a geopolitical trigger. History shows how easily astronomical discoveries can shift power balances, from Galileo's telescopes challenging authority to Sputnik sparking the space race. 4i could be the next such spark. In the end, these windows into the future converge on one truth. Our attempts to predict 4i say more about us than about the object itself. Whether through algorithms, stories, or strategy, we are preparing for something that has not yet happened, and in that preparation, we are revealing our hopes, fears, and blind spots. Forecasting the arrival of 4i is not just a scientific challenge. It has become almost prophetic, echoing the way past civilizations look to the stars for omens. Prophetic visions and speculation. Throughout history, unusual celestial events have been linked to prophecy. Ancient Chinese court astronomers recorded comets as harbingers of dynastic change. Medieval Europeans feared them as signs of plague or divine wrath. Today, the cultural role of prophecy has been replaced by science fiction, documentaries, and viral speculation on platforms like YouTube. Yet the mechanism is the same. The sky becomes a mirror of our anxieties. When 4i arrives, it may be wrapped in not only data, but myth, each interpretation telling us less about the object itself and more about human imagination. Arrival timelines and cosmic weather reports. Some researchers have begun to frame interstellar visitors the way meteorologists frame storms. Instead of a 5-day weather forecast, they sketch arrival probabilities. Within the next 5 years, we should expect another 2i Borisov-sized object. Within the decade, something larger. These timelines are rough, but they create a sense of anticipation, a countdown that resonates with both scientists and the public. It transforms astronomy into a watchtower discipline, with Earth positioned as the lookout on the edge of a galactic sea. The paradox of forecasting. Ironically, the more we focus on forecasting 4i, the more it changes our relationship to the unknown. If we convince ourselves that the next visitor will arrive in 2 years, we prepare missions, set expectations, and shape narratives around that date. But the universe does not conform to our schedules. 4i might appear tomorrow or not for 20 years. In preparing for one window, we risk blinding ourselves to others. Forecasting, by design, shapes the very readiness it seeks to measure. Shaping readiness. Still, the effort is not wasted. By running scenarios, by imagining outcomes, by testing public reactions, humanity rehearses. Each forecast, each speculative paper, each cultural story is part of a vast rehearsal for the day when 4i is finally real. The value may not lie in predicting the exact moment, but in ensuring that when it comes, we are not caught paralyzed. For every interstellar object we detect, dozens, maybe hundreds, slip past unseen. These are the quiet visitors, bodies that leave no glowing tale, no easy signature, and no dramatic story in the news. Astronomers know this because of probability. The detection of 3 confirmed interstellar visitors in less than a decade, ʻOumuamua 2017, Borisov 2019, and Atlas 2025, suggests not rarity, but abundance. If even our limited telescopes can stumble upon 3 in quick succession, then the galaxy must be teeming with wanderers. The silence of our instruments tells us only that we are not looking in the right ways, or not often enough. The quiet visitors may be dark rocks, absorbing sunlight rather than reflecting it. They may be small, boulders or pebbles flung from shattered worlds. They may even be icy bodies that never approach the sun closely enough to sublimate, remaining invisible against the starfield. For us they are ghosts brushing past Earth in silence, and yet their presence is undeniable. Some leave faint traces in meteor showers, exotic particles in the upper atmosphere, chemical ratios that don't match anything in our solar system. Others reveal themselves in hindsight, when astronomers comb through archived data and find a faint streak in a frame that went unrecognized at the time. Each rediscovery is like realizing you missed a stranger brushing your shoulder in a crowded street. The unsettling truth is that Earth is not a bystander in this traffic. It is immersed in it. At any given moment, unknown objects may be crossing the solar system, some close enough to alter our understanding of planetary defense, most pass silently. But one day, a quiet visitor might not. Imagine this. 4i does not blaze across our telescopes like Borisov, or puzzle us with strange acceleration like ʻOumuamua. Instead, it slips through as one of the ghosts, an object so dark, so faint, or so strangely angled against the glare of the sun that we only recognize it after it's gone. This is not speculation. Astronomers have already identified candidates in archived data. Faint streaks dismissed as noise that, when reanalyzed, reveal interstellar velocities. Each one is a missed opportunity, a message we never read. If 4i follows this pattern, the world may only learn of its passage months or years too late, when the chance to study it is lost forever. The implications are chilling. Humanity would be living through encounters with alien messengers without ever knowing. They could have skimmed Earth's orbit, passed Jupiter, or drifted just beyond Neptune, carrying stories from other star systems, and our instruments simply never noticed. 4i might not be a singular event waiting in the future. It might be an event already in the past, recorded only in faint echoes hidden in terabytes of sky survey data. But this possibility carries a paradox. If we cannot see these quiet visitors, then how do we prepare for them? The answer lies in shifting perspective. Instead of waiting for a glowing comet tail, we must train ourselves to see the invisible, the infrared shimmer of heat against cold space, the subtle gravitational tug on nearby bodies, the statistical outliers in streams of orbital data. Because if 4i is a quiet visitor, it will not announce itself. It will arrive as a whisper, a shadow, a data point buried in noise. And perhaps the real challenge is not whether it comes, but whether humanity has trained its eyes, its machines, and its imagination to recognize it in time. When Oumuamua passed through our solar system, astronomers debated whether its strange acceleration could be explained by outgassing, yet no coma was ever detected. Borisov, by contrast, looked every bit like a classic comet, with its icy tail blazing in the sun. Atlas fell somewhere in between, whispering puzzles instead of answers. What these cases teach us is unsettling. Our instruments are tuned for the familiar, not the alien. We expect bright tails, predictable trajectories, standard chemistry. Anything outside those boxes risks being misclassified or ignored. Consider how much we might be missing. Spectral anomalies. Many telescopes filter out unusual spikes in their data as noise. But what if those spikes are real? A material unknown to Earth chemistry, or an engineered alloy reflecting starlight differently, could be discarded before anyone notices. Geometric regularities. Automated detection systems look for natural randomness, roundish rocks, icy fuzz. But what if 4i were not a rock at all but a structure, angular, geometric, deliberate? Our algorithms might dismiss it as an error, failing to register what human eyes would recognize instantly: design. Whispers of biology. Even more provocative, some scientists speculate that interstellar visitors could carry life's building blocks, spores, organics, microfossils. Yet the faint biosignatures of such materials could be invisible against cosmic dust. Without direct sampling, we would never know. In other words, we are not just at risk of missing 4i, we are at risk of misidentifying it when it comes. And there's a deeper layer of unease. What if someone has already seen signals and chosen not to share them? Astronomical data is gathered by thousands of observatories worldwide, but access is not equal. Governments classify, corporations patent, and even universities hold data until publication. The story of 4i could already exist, locked in some server, unseen by the public eye. If there is one lesson from the history of discovery, it is this: signals can be overlooked not just by accident, but by design. The politics of data. Every night, observatories around the globe gather terabytes of raw sky data. Most of it never sees the public. Proprietary periods protect researchers' claims, governments classify strategic findings, and institutions prioritize funding. This means an anomaly in the night sky may be catalogued but not disclosed, sometimes for years. If 4i carries odd emissions or unexplained dynamics, it is possible someone has already logged them, yet the information remains hidden, waiting to be released only when convenient. The fragility of perception. Even when data is open, perception filters the truth. In 1967, Jocelyn Bell Burnell detected a perfectly regular radio signal. At first, her team half-jokingly labelled it LGM-1, Little Green Men 1. It turned out to be a pulsar, a natural phenomenon. But what if next time it isn't? How many other LGMs have been filed away as anomalies, their signals dismissed under the pressure of caution? Philosophical consequences. If 4i arrives bearing signals we miss, geometric echoes, engineered alloys, strange accelerations, what does that say about us? That the universe is silent, or that we are deaf? There is a haunting possibility that civilizations might regularly cross one another's paths, yet each is too blinded by its own instruments, its own filters, its own bureaucracy to notice. A silence not of space, but of interpretation, accident or secrecy. The sharpest question is whether these blind spots are merely the limitations of human science, or if secrecy plays a larger role. Governments know that public panic can destabilize economies, spark religious upheavals, and fuel geopolitical competition, the temptation to keep quiet until certainty is overwhelming. But certainty rarely comes in astronomy. By the time we know with confidence, the moment has passed. 4i could carry signals, and history might remember us not as the species who discovered them, but as the species who ignored them. If we want to glimpse the shape of 4i, we must look backward, at the three messengers we've already met. Each was different, yet together they sketch a pattern that may define the future of interstellar discovery. ʻOumuamua, 2017. The first. The Trailblazer. A slender, elongated body racing out of the constellation Lyra, spinning end over end. Its brightness fluctuated strangely, hinting at a flattened, tumbling form. Then came the puzzle. Its trajectory shifted in ways sunlight alone could not explain, yet no gas, no tail, no visible jets accompanied it. The debates began. Icy shard, hydrogen iceberg, alien light sail. What made ʻOumuamua haunting was not what it showed us, but what it refused to reveal. 2i Borisov, 2019. The second. The confirmation. Borisov was everything ʻOumuamua was not. A classic comet, complete with glowing coma and streaming tail. It behaved exactly as textbooks predicted, outgassing, fragmenting, fading as it neared the sun. To many astronomers, Borisov was a relief. It proved that interstellar visitors could resemble the comets we already knew. But its chemistry told a different story. Ratios of carbon and water unlike anything found in our solar system, whispering of alien chemistry, of worlds born under different suns. 3i Atlas 2025, the third, the Enigma. Atlas straddled the line between comet and something stranger. Its emissions began earlier than physics allowed, its trajectory showed suspicious alignments with planetary orbits, and its composition, an unusual carbon dioxide dominance, ignited speculation. For some, it was merely another odd rock. For others, it was a signal, a body behaving less like debris and more like a mission. Taken together, these three teach us a lesson. ʻOumuamua showed us mystery without evidence. Borisov gave us evidence without mystery. Atlas combined both, a riddle that resists dismissal. If the first three are stepping stones, then 4i may not just continue the pattern. It may culminate it, blending anomaly and familiarity into something impossible to ignore. Beyond their physical mysteries, the first three interstellar visitors reshaped how humanity imagines the cosmos. Each arrival carried not just data, but stories that influenced science, politics, and culture in equal measure. ʻOumuamua, the cultural spark. Its discovery in 2017 came at a moment when the world was already hungry for cosmic wonder. Social media amplified every theory, from hydrogen icebergs to alien probes. Scientists battled over caution versus speculation, while the public embraced the mystery. ʻOumuamua became less an object and more a cultural archetype, proof that the universe might be stranger than textbooks dared admit. 2i Borisov. The anchor of normalcy. Borisov in 2019 offered balance. It looked familiar, it behaved predictably, and it reassured skeptics that ʻOumuamua was not rewriting physics after all. Yet beneath its ordinary appearance lay chemical surprises, molecular ratios unlike anything seen before. The lesson was subtle. Even the familiar hides the alien. This duality helped normalize the idea that interstellar visitors were not singular miracles but recurring events. 3i Atlas, the alarm bell. Then came Atlas in 2025. Where ʻOumuamua sparked curiosity and Borisov reassured, Atlas unsettled. Its suspicious alignments, anomalous chemistry and premature activity raised whispers that could not be silenced. Governments tightened language. Scientists grew cautious in their phrasing. But the public imagination surged ahead, weaving tales of mission-like behavior and hidden agendas. Atlas taught us that sometimes the story cannot be contained. that data itself can ignite suspicion when it hints at intent. Taken together, the first three formed a trilogy of lessons. Mystery, ʻOumuamua. We cannot assume the universe behaves as expected. Familiarity, Borisov. Even the known can surprise us. Alarm, Atlas. Some visitors may not simply pass. They may provoke questions we are not ready to answer. And so, when 4i arrives, it will not be greeted as a blank slate. It will arrive in the shadow of these stories. Every spectrum, every trajectory, every anomaly will be filtered through the memories of the first three. It will not just be another object. It will be a continuation of a narrative we have already begun writing. The question, then, is not only what will 4i be, but what story will humanity choose to tell about it? By the time 3i Atlas unsettled astronomers in 2025, one truth had already begun to sink in. Interstellar visitors are no longer rare enough to ignore. A decade ago, ʻOumuamua was treated as a once-in-a-lifetime anomaly. Now, scientists speak openly of a steady flow, a cosmic traffic of which we have only glimpsed a few lanes. That shift in perspective has pushed humanity into a new phase: preparation. International scientific efforts research centres from Hawaii to Chile have begun pooling resources. The Vera C. Rubin Observatory's upcoming surveys are designed not just for asteroids, but to flag the faint telltale motion of hyperbolic travellers. Meanwhile, the European Space Agency and NASA are discussing cooperative missions, spacecraft on standby trajectories that could be launched quickly to chase the next 4i. These are not fantasies, they are draft mission concepts, budgets penciled into the coming decades, political interest and rivalries. But science does not move in a vacuum. Where knowledge goes, politics follows. China has hinted at including interstellar intercept missions in its next generation of deep space plans, while the United States frames such projects as a matter of national security. To some officials, 4i is not merely an opportunity to study cosmic debris, it is a potential geopolitical prize. Whoever reaches it first might claim not only prestige, but exclusive access to material forged in alien suns. Public messaging and secrecy. Meanwhile, agencies continue to refine their communication strategies. The lesson of ʻOumuamua was that silence breeds speculation. The lesson of Atlas was that openness can spark panic. When 4i comes, messaging will be as critical as detection. Will governments describe it in calm, clinical terms? Or will the first leaks emerge from citizen astronomers, sparking viral narratives before official voices can respond? In an era where information spreads faster than light, control of the story may matter as much as control of the data. Psychological readiness. Finally, there is the matter of human readiness. Psychologists working with space policy groups warn that the arrival of 4i could trigger cascades of cultural reaction. Religious interpretations, conspiracy theories, speculative markets. Preparations for 4i are not only telescopes and rockets, they are also frameworks for managing belief, fear, and hope. Preparation does not only mean building telescopes. It means asking questions about what 4i truly represents and how humanity should respond when it finally appears. Mission concepts and intercept scenarios. One of the most ambitious proposals is the Interstellar Interceptor, a spacecraft waiting on a parking orbit, fueled and ready to launch within days of detection. Instead of missing the fleeting window, we could chase 4i up close, capture images, maybe even take samples. The European Space Agency has floated a comet interceptor model, originally designed for unknown comets, which could easily pivot to an interstellar visitor. NASA has run similar studies, but the challenge remains funding. Are we willing to spend billions preparing for an event that might not occur for 10 years or might occur tomorrow? Defense versus discovery. Another layer of preparation veers toward defense. Atlas, with its odd emissions and suspicious alignments, reminded policymakers that not all interstellar visitors will be greeted with trust. If one day a visitor appears on a path uncomfortably close to Earth, the line between comet science and planetary defense will blur. Military analysts have already speculated on whether interstellar objects could be misinterpreted as weapons, or worse, used as such. Preparing for 4i means preparing not just to study but to respond, the object as the message. Then there is the deeper philosophical question. Must contact mean intelligence? Or is the arrival itself a kind of message? Each interstellar visitor is a fragment of another world, ejected from a system we may never see. To study one is to hold in our hands matter older than Earth, shaped under alien suns. Even if 4i is lifeless, inert, without intention, it is still a form of cosmic communication. It tells us we're not isolated. The galaxy touches us. Preparedness beyond science. Preparation, then, cannot be confined to labs and mission blueprints. It must extend to classrooms, to cultures, to the stories we tell ourselves about our place in the universe. The question of 4i is not just when it arrives, but whether we are ready, scientifically, politically, emotionally, to face what it represents. Perhaps the strangest part of the story is not the visitors themselves, but the silence between them. Humanity now lives in a state of cosmic anticipation, watching the skies, waiting for the inevitable moment when the designation 4i appears in headlines. This waiting has become almost a discipline in itself, shaping science, culture, and psychology. The scientific patience for astronomers, waiting is both familiar and exhausting. Discoveries depend on long nights of scanning sky fields that often yield nothing. Years can pass between detections. The pressure is enormous. The first person to log 4i will etch their name into history, but they must endure the grinding monotony of false positives, noise, and data gaps. The wait becomes a test of endurance as much as intellect. The cultural expectation. For the public, the wait has taken on the quality of a countdown. Social media speculates. Where is 4i? Why hasn't it arrived yet? What if it never does? Each day without discovery fuels both skepticism and heightened anticipation. The longer the pause, the greater the wait on the moment of arrival. If 4i comes tomorrow, it will be seen not just as another object, but as the climax of years of suspense. The psychological strain. There is also a quieter toll. For some, the wait carries hope, the hope of confirmation that we are not alone, that the universe is connected by more than silence. For others, it carries dread, the fear that 4i might prove hostile, or that it may force us to confront truths we are not ready to face. Psychologists describe this state as anticipatory anxiety, the stress of waiting for an event you cannot predict or control. The silence as story. In a way, even the absence of 4i is telling a story. It fuels theories that Atlas was no accident, that ʻOumuamua was more than rock, that the galaxy is watching us with intent. Each year without 4i adds weight to those narratives, giving the silence itself a kind of voice. The waiting becomes a stage on which humanity projects its deepest fears and desires. Waiting has a weight. The absence of 4i is not an empty silence, but an active force, shaping decisions on Earth before the object itself even arrives. Science and funding pressures. The longer the wait, the harder astronomers must fight for resources. Politicians and funders ask, if these visitors are common, why haven't we seen another since Atlas? This paradox fuels both skepticism and urgency. Projects like the Rubin Observatory or NASA's NEO Surveyor find themselves framed as insurance policies, not just for planetary defense, but for the chance to catch the elusive 4i before it slips away. Silence is expensive, but it is also motivating. The rise of cultural myth-making. Culturally, waiting breeds mythology. In forums, documentaries, and online communities, the absence of 4i is filled with speculation. Maybe governments already know. Maybe 4i is here and hidden. Maybe Atlas wasn't a comet at all, but a deliberate act. Each year without confirmation strengthens these narratives, weaving conspiracy and wonder into the story of the fourth visitor. The longer the gap, the more mythic its eventual arrival will feel. Geopolitical narratives. At the global level, anticipation is not idle. Rival nations track sky surveys, quietly fearing that the next detection will become a geopolitical weapon. If one power claims 4i first, it may claim ownership of the data, the samples, even the narrative. In this way, the wait for 4i becomes a stage for political maneuvering. Silence is not neutral. It is a resource to be managed, exploited, or contested, the weight of the unknown. And finally, there is the human heart. Waiting for 4i is waiting for the unknown itself. Each night, each survey, carries the unspoken question, will tonight be the night? Will today be the day? That anticipation changes how we see the stars. It turns astronomy into prophecy and transforms cosmic chance into destiny. When we ask when will 4i arrive, we are also asking what form will it take? Will it resemble the strange cigar of ʻOumuamua, the icy comet of Borisov, or the engineered enigma of Atlas? Or will it be something so new that none of our categories can contain it? Echoes of the past. ʻOumuamua taught us that interstellar objects can look nothing like the asteroids or comets we know. Its flattened, elongated form, tumbling end over end, forced astronomers to abandon the comfort of familiar labels. Borisov reassured us with its cometary tail, a sign that some visitors behave as expected. Atlas, however, unsettled us again, its chemistry, alignments, and behaviour whispering of intent. The fourth visitor will not arrive into a vacuum of interpretation. Its very shape will be compared against these three. Scientists will scrutinise it for resonance. Is it a natural cousin or a deliberate departure? Possible archetypes: the silent shard, a rocky, featureless body, offering no signs of activity. Such an arrival would disappoint some but still force questions about the abundance of rocky wanderers in interstellar space. The living comet, like Borisov, trailing gases, glowing with volatile release. If 4i comes this way, it may restore faith in natural explanations, or mask something deeper. The engineered vessel, Atlas, has made this option impossible to ignore. A body that behaves with precision, with emissions that resemble thrusters more than physics. Its shape may mimic natural rock, but its scars, seams, or alignments could betray intelligence. The impossible form. What if 4i defies geometry altogether? A fragment shaped like a sheet, a hollow lattice, a spinning construct that seems more artifact than accident. If such a form arrives, it could challenge not only science but philosophy. A mirror of expectation. And yet, what 4i looks like may matter less than what we project upon it. To astronomers, it will be data curves and spectra. To the public, it will be myth, a messenger, a weapon, or a god. The fourth visitor will not only reflect light from distant suns, it will reflect our deepest hopes and darkest fears. Cultural lenses of perception. Every civilization across every age has looked up at the sky and seen stories. To the Babylonians, comets were harbingers of doom. To the Chinese court astronomers, they were broom stars, sweeping old eras away. To Renaissance Europe, they were divine warnings. And now, in the 21st century, the arrival of 4i will ignite the same instinct, to interpret, to mythologize, to fear. If 4i appears jagged and lifeless, it will be cast as the sword of Damocles, an omen of destruction. If it glows softly, haloed by gas, it may be imagined as a celestial seed, a messenger of renewal. But if it shows seams, symmetry, or movement beyond what physics demands, then it will not be a rock. It will be a revelation. Psychological shock Atlas has already prepared us for suspicion. People are primed to look for the artificial, to imagine design in randomness. 4i will arrive into a world armed with conspiracy theories, deep fakes, and mistrust of institutions. If governments declare it harmless, many will not believe them. If they declare it an anomaly, many will whisper the word craft. The shock will not come from its size or orbit, but from its implications. If it is engineered, it proves intelligence beyond us. If it is natural, its strangeness still proves that the galaxy is restless, filled with debris, wanderers, and messengers we have only begun to catalogue. Cinematic possibilities. Imagine the first images, a gleaming shard backlit by the sun, spinning with unnatural regularity. A hollow lattice of frozen gas and dust, like scaffolding around nothing. A metallic body bristling with structures too geometric to be chance. The telescopes will feed us pixels, but the human mind will see meaning. Each frame will become an icon, endlessly replayed on screens, analysed for signs of doors, patterns, or signals. The mirror we cannot escape. Ultimately, 4i's shape will not only tell us what it is, it will tell us what we are. A civilization that sees fear may prepare for war. A civilization that sees opportunity may prepare for contact, and a civilization split between those visions may discover that its greatest challenge is not the visitor itself, but the reflection of humanity it forces us to confront. Every interstellar visitor so far, ʻOumuamua in 2017, Borisov in 2019, Atlas in 2025, has arrived without warning. We didn't predict them decades in advance. We stumbled across them as they were already racing through the solar system. This means the question, when will 4I arrive, isn't just about astronomy. It's about probability, about vigilance, and about how prepared we are to see the next messenger before it's too late. Astronomers track the rate of discoveries through wide-field sky surveys like Pan-STARRS in Hawaii, Catalina in Arizona, and the Vera Rubin Observatory now coming online in Chile. Each year, the number of detected comets and asteroids increases, sharpening our odds of spotting another interstellar intruder. Statistically, we expect one every 5 to 10 years. If ʻOumuamua was first, Borisov second, and Atlas third, the clock is already ticking for 4I. Probability windows. If the pattern holds, 4I should arrive within the next decade. Perhaps as soon as 2027, perhaps not until 2035. But here's the unnerving part. The clustering of these events may not be random. 3 visitors in less than a decade after centuries of none, that is not easily explained by chance alone. Either our technology has just now become good enough to see what was always happening, or the galaxy is suddenly sending more. Some theorists whisper about streams of interstellar debris, long trails of objects expelled by violent events around other stars. If Atlas was part of such a stream, then 4I might already be inbound, riding the same invisible river of ejected fragments. The human timeline. We measure time by calendars, elections, lifetimes. But the cosmos measures in eons. The arrival of 4I will crash those scales together. If it comes tomorrow, the world may not be ready. If it comes in 2035, humanity will be older, perhaps with colonies on the Moon or Mars, a stronger space infrastructure, maybe even a defense strategy. The difference of a few years could shape how we interpret its arrival, as an existential threat or as an opportunity for dialogue. First contact with the data. It begins quietly, like every great astronomical discovery does, with a dim speck moving across a survey image. An intern at the Vera Rubin Observatory notices a streak on the night's data, cross-checks it against known comets and asteroids, and realizes it doesn't match. Within hours, a flurry of emails lights up global networks of astronomers. The orbit is hyperbolic. It is not bound to the Sun. A designation is given, 4I, the 4th confirmed interstellar visitor. At first, there is celebration. News headlines proclaim another messenger from the stars. But then the details arrive. Its trajectory is not a flyby like Borisov, not a grazing encounter like ʻOumuamua. Instead, it is heading directly into the inner solar system, threading a course alarmingly close to Earth's orbit. The critical 72 hours. Day 1. Astronomers confirm 4I's origin. It is real, not an artifact. Its velocity suggests it came from beyond the nearest 50 light-years. Day 2. Spectroscopic analysis reveals unexpected chemistry, metallic lines, exotic isotopes, something that doesn't look like random cosmic ice and dust. Day 3. Governments are briefed. NASA, ESA, Roscosmos, CNSA all declare emergency review boards. But in the age of social media, the story leaks before officials can contain it. By the end of the first week, number 4I arrival trends worldwide. The public reaction. For ordinary people, the news doesn't sink in immediately. Another comet, another rock. But when space agencies hold back data, conspiracy theories explode. Some claim it's an arc, others say it's a weapon. The tension grows with every update. Markets dip. Military satellites are tasked with tracking it. Private space companies quietly reroute missions, knowing public fear could topple their funding if the worst is true. The countdown. In the following months, humanity waits. Each day brings sharper images. First a fuzzy dot, then an elongated body, then, perhaps, features that don't look natural at all. For scientists, it's the chance of a lifetime. For governments, it's a potential crisis. For the public, it is a psychological earthquake. Because the arrival of 4I is not just about astronomy anymore. It is about whether we are ready to live in a galaxy where wanderers keep coming. Whether they are debris, probes, or emissaries, one thing is certain, 4I will not be the last. The memory of the sky. Long before telescopes, long before spectroscopy or orbital mechanics, human beings looked up at the heavens and read meaning into what they saw. A comet wasn't just a dirty snowball, it was a message. A star that wandered where it shouldn't was an omen. Across cultures, sudden lights in the sky carried weight far beyond their physical reality. When we imagine 4i's arrival, we cannot separate it from this deep human reflex. The way we react today echoes the way ancient civilizations once trembled at the sight of Halley's comet, or at guest stars that appeared without warning. In their eyes, the universe was speaking, and now, as 4i crosses into our solar system, many will feel the same, that the cosmos has chosen to speak again. Ancient omens, modern visitors, consider China's meticulous astronomical records. For over 2,000 years, imperial astronomers logged broom stars, fiery visitors that appeared and vanished. These records weren't just science, they were warnings, guiding emperors in matters of war, agriculture, and diplomacy. The arrival of 4i might echo that pattern, leaders watching the skies quietly recalibrating their policies, fearing that public panic could ignite if the object reveals more than it should. Or take the Norse sagas, tales of flaming serpents crossing the heavens, seen as heralds of Ragnarok, the end of days. To Viking eyes, 4i's path might have looked like prophecy fulfilled. In the Middle East, the appearance of new stars or comets was often tied to the fate of kings. In Mesoamerica, bright strangers in the night sky carried messages from gods who shaped the cycle of creation and destruction. The psychology of repetition. This is where things get unsettling, because when the public hears 4i, they won't just think of science, they'll think of pattern. The first was ʻOumuamua in 2017, the second, Borisov in 2019, the third, Atlas in 2025, now a fourth. To many, this feels less like coincidence and more like cadence, a drumbeat, a countdown. Astrophysicists may argue about trajectories and probabilities, but ordinary people, watching headlines flash across their phones, will default to story, to omen, to anticipation that something or someone is deliberately sending these wanderers our way. Governments and quiet protocols. Whenever a new interstellar visitor is announced, public-facing agencies issue statements of reassurance. It poses no threat to Earth, NASA insists. It's just another comet, the ESA echoes. But behind the curtain, the calculus shifts. Defense departments draft contingency plans. Space surveillance networks refine their orbital models hourly. Why? Because leaders know the psychological impact. If the public begins to see these arrivals not as random but as coordinated, fear will spread faster than data can disprove it. Quietly, task forces prepare for cultural fallout. Religious leaders are briefed in advance to help manage interpretation. Stock markets brace for volatility. Even the United Nations Office for Outer Space Affairs, normally ceremonial, updates language and treaties to consider extraterrestrial artifacts. No one wants panic, but no one wants to be unprepared either. Religious reverberations. Across faiths, the skies have always been a canvas for divine intent. When 4i arrives, sermons and prophecies will ignite. Some will see it as fulfillment, a herald of change, perhaps even judgment. Evangelical groups may link its appearance to apocalyptic scripture. In Hindu cosmology, some might frame it as another cycle in the endless dance of creation and destruction. In indigenous traditions, storytellers may recognize patterns passed down for centuries, interpreting 4i not as stranger but as returning ancestor. Religion has the power to calm or inflame, and history shows both outcomes. Halley's comet in 1910 sparked mass hysteria when tabloids claimed its tail would poison Earth. Yet in other cultures, comets were seen as protectors or guides. 4i could be either, depending on who controls the narrative. Popular culture as prophecy. Meanwhile, cinema and media will blur fact with imagination. Movies about alien motherships, novels about hidden probes, viral TikToks about countdowns to invasion, all will shape perception as much as official press conferences. The line between entertainment and information is thin, and in an age of algorithm-driven feeds, the scariest version of 4i's story is the one most likely to spread. Just as ʻOumuamua became the interstellar probe in public discourse despite a lack of evidence, 4i will be mythologized in real time. Every unusual data point, A strange spectrum, a non-random trajectory, a delay in official reporting will be dissected online and amplified into meaning. In the collective imagination, 4i won't just be a rock. It will be a messenger, a test, a warning. The drumbeat continues, and so the pattern strengthens. 1i, 2i, 3i, now 4i. For scientists, these are chance encounters in the vast lottery of celestial dynamics. For the public, they are signs, and as the cadence continues, the expectation grows heavier, that the 5th, 6th, or 7th may not simply pass by. That one will stay, that one will act. The truth may be mundane, planetary debris cast off in the chaos of star formation, but humanity has never treated visitors from the sky as mundane. Our myths won't let us. Our fears won't let us. Our imagination won't let us. The odds we're supposed to believe astronomers remind us constantly. Space is vast, collisions are frequent, and planetary systems eject debris like sparks from a fire. By their logic, interstellar objects must pass through our solar system with some regularity. But here's the paradox. Until 2017, we had never seen one. 4.5 billion years of solar system history, and only in the past 8 years have we detected 3 confirmed interstellar visitors, and now await the 4th. If interstellar objects were truly so common, why did we not notice them before? The official explanation is that our instruments weren't sensitive enough. Wide-field surveys like Pan-STARRS, the Zwicky Transient Facility, and ATLAS only recently gained the ability to detect faint, fast-moving objects against the background stars. That's plausible, but is it the whole story? The suspicious rhythm, 1i ʻOumuamua, 2017, 2i Borisov, 2019, 3i Atlas, 2025, and now whispers of 4i looming in probability models. The timing forms a rhythm, a drumbeat across the heavens. Not random arrivals over millions of years, but clustered within a single human lifetime. In statistics, clustering can happen by chance. But in mythology, clusters are omens. For the public, the fact that these arrivals are so recent creates a chilling undertone. Maybe they're not random at all. Maybe something has changed in the galaxy, or maybe something has changed in us. Perhaps our species has finally been noticed. Ejection versus intention. The mainstream view is clear. Interstellar comets are debris flung outward by the gravitational chaos of young planetary systems. Giant planets hurl trillions of icy bodies into the void, most doomed to wander eternally between stars. Eventually, a handful pass through our neighbourhood, but if the ejection theory is correct, then these should be countless, scattered, and directionless. Yet the ones we've detected share unsettling similarities, unusual trajectories, odd chemistries, accelerations that don't align with expectations. Some researchers dismiss these as observational artifacts. Others, quietly, admit that something about this pattern feels guided. When 3 unusual arrivals all fall within a single decade, the line between coincidence and design blurs. And when the question shifts to when will 4i arrive, the answer stops sounding like a matter of probability and more like a countdown. The thought experiment becomes less abstract the more we examine the consequences. If 4i arrives in the near future, and if its behaviour mirrors or escalates beyond that of its predecessors, then humanity is staring down not just a new discovery, but a new era of cosmic identity. Civilization at the edge of disclosure. Imagine the first images, a distant dot on a telescope feed, then a streak, then an object accelerating in ways that raise eyebrows even at NASA. Leaked memos circulate, the news cycle ignites, governments scramble to coordinate, not simply because of curiosity, but because of fear. What if this is the one that doesn't pass through harmlessly? What if this is the visitor that stays? The psychological shock of 4i's announcement would reverberate faster than its orbital parameters. Markets tremble, conspiracy forums explode, and whispers of extraterrestrial intent leap from fringe discussions into mainstream headlines. We have rehearsed the idea in science fiction for decades, but reality has no script, only uncertainty. The point of no return. The real threshold is not scientific, but existential. If 4i is discovered to harbour anomalies, unexpected chemistry, unexplained accelerations, or worse, signals, then the old debate about whether we are alone collapses instantly. The universe ceases to be indifferent background. It becomes interactive. At that moment, humanity's timeline forks. Path 1. 4i is natural, and we adapt, study, and eventually normalize its passage, building new astronomy and planetary defense tools. Path 2. 4i is deliberate, and we are forced to confront intelligence older, larger, and perhaps more powerful than ourselves. Both paths lead to change, but only the second forces us into the greatest confrontation of all, with our own fragility. The echo of the first 3 ʻOumuamua made us suspicious. Borisov confirmed abundance. Atlas made us uneasy. But 4i? 4i would be the answer into whether the sequence is a coincidence or a communication, whether we are alone or already surrounded. What terrifies scientists isn't the arrival itself, it's the implication of rhythm, a rhythm that suggests purpose, a rhythm that suggests that 4i is not just a rock, but a message, and once it arrives, there will be no going back. When astronomers speak of a last signal, they do not mean melodrama. They mean the precise instant where uncertainty collapses into knowledge, the faint spike in a spectrograph, the jitter in a radio channel, the image that refuses to behave like noise. For 4i, the last signal will be the hinge on which everything turns. Discovery becomes verdict, possibility becomes policy, rumour becomes history. How discovery really happens. Discovery rarely arrives as a Hollywood trumpet. It begins as data, a streak across a wide-field frame, a transient flagged by an algorithm, an anomalous line in a spectrum that an intern notices at 3 a.m. That tiny observation triggers protocols. The object is cross-checked, its apparent motion verified, its orbit estimated. Within hours, networks share the finding. Within a day, other telescopes point and verify. The last signal is not always a loud single event. Sometimes it is the accumulation of many small confirmations that, together, leave no reasonable doubt. For 4i, the last signal could take multiple forms, an orbital solution showing a hyperbolic excess velocity incompatible with solar system origin. A spectral fingerprint with isotopic ratios or elemental lines that do not match known solar system materials. A non-gravitational acceleration that persists after careful accounting for outgassing and radiation pressure. A patterned radio emission, narrowband, coherent or pulsed, rising above the background and replicable by multiple observatories. Each carries different consequences. An orbital solution announces provenance. A spectrum reveals composition. An unexplained acceleration forces reinterpretation of dynamics. A deliberate radio pattern would be, in ordinary language, a message. The chain reaction, science is methodical, but the moment of the last signal transforms method into motion. Here is how it plays out. Verification. The first team posts their alert. Other teams scramble to observe. Peer checks either confirm or refute. In modern practice, multiple independent detections are required before public release, but in the internet age, leaks often preempt formal announcements. Classification. If the orbit is hyperbolic, the object is categorized as interstellar. If spectroscopy shows familiar cometary lines, scientists breathe a cautious sigh. If the data refuses simple classification, alarm levels rise. Consultation. Observatories, mission planners, SETI groups, and national agencies begin private calls. What did you see? Becomes the urgent question. The tone of the conversation, calm, curious, or tense, often determines the next public posture. Public messaging, scientists negotiate statements. We have detected an interstellar object is different from, we have detected anomalies consistent with artificial action. How the message is framed will shape reaction. Operational response. If the object's behavior threatens to linger or to approach sensitive regions, agencies consider accelerated observation campaigns, potential robotic intercept concepts, or classified briefings to military and political leaders. The last signal is, therefore, bureaucratic as much as astronomical. It is data congealed into consequence. The many faces of the final cue. We must accept that the last signal could be ambiguous. History offers lessons. Ambiguous spectral lines can be dismissed as instrumental artifacts until multiple spectrographs confirm them. Transient radio pulses may mimic natural phenomena, pulsars, scintillation, until patterns repeat. Non-gravitational motion can be explained by outgassing in comets, by thermal forces on tumbling bodies, by radiation pressure on thin sheets, or by propulsion. A critical risk is false positives, declaring a signal to be extraordinary when it is ordinary. False alarms degrade trust. But the opposite error, insisting on absolute certainty before warning the public, risks appearing to hide critical information. Governments and scientists walk this razor daily. The last signal must therefore be handled with procedural clarity and moral humility. The last signal is not a single moment, but a spectrum of possible endings, each with vastly different implications. Let's explore 3 scenarios, from the most mundane to the most world-shattering, and how humanity might respond to each. Scenario 1. The innocuous signal. Astronomers track 4I's orbit. It behaves as expected, hyperbolic, inbound, then outbound. Spectra show standard cometary volatiles. Its outgassing fits established models. The anomaly lies only in its interstellar origin. Outcome: public interest rises, then fades. Headlines shout, "Another ʻOumuamua," before attention drifts. Scientific papers dissect details, but the world keeps spinning. This is the scenario that soothes governments. It preserves order. It allows the public to believe that the universe is interesting but not alarming. Scenario 2. The ambiguous signal. Here lies danger, not in certainty, but in doubt. 4I emits a faint radio pulse near the hydrogen line, but only once, or it deviates slightly from its expected path, with no clear physical explanation, or it exhibits spectral lines inconsistent with solar system chemistry, but not conclusively artificial. Outcome: scientists argue fiercely in journals and at conferences. Governments issue cautious statements, hedging their words. Conspiracies explode, one camp screaming cover-up, another screaming hoax. Ambiguity is corrosive. It divides institutions, erodes trust, and destabilizes the information landscape. The real risk here is not what 4I is, but what humanity does when certainty refuses to arrive. Scenario 3. The definitive signal. The telescope arrays confirm it: repeated, narrowband, coherent emissions, or a trajectory that can only be explained by active propulsion, or imagery revealing geometric structures on the surface that no geology could mimic. Outcome: science, paradigms collapse, SETI protocols activate, multiple observatories verify. The Rio scale rating spikes to 8 or 9 as civilization altering. Governments, emergency sessions convene, defense ministries scramble, psychological preparedness documents are dusted off. Public, awe, terror, fascination. Religious leaders reframe theology. Conspiracy forums burst into vindication. History, this becomes the fulcrum. Before 4I, after 4I, the definitive signal ends the long night of cosmic silence. It is the answer to a question older than humanity itself, but it may be the answer we are not ready for. The larger truth. Whether innocuous, ambiguous, or definitive, the last signal teaches us that the cosmos is not passive background. Each interstellar visitor, each signal, each anomaly shifts the center of our story. 4I may be the final rehearsal before the curtain rises on an epoch where the universe is not merely observed but encountered. And that encounter, once it comes, cannot be undone. There is a strange silence that follows the first detection. Telescopes turn, data streams pour in, chatter fills encrypted channels. But for the wider world, the days or weeks between discovery and confirmation become a kind of cosmic limbo. Humanity waits, not knowing if the visitor is trivial or transformative. The weight of anticipation. Psychologists have long studied the tension of uncertainty. Whether in medicine, war, or disaster, it is the waiting that unravels people more than the outcome. The same applies to astronomy. Scientists know data takes time, models must converge, peer review must filter error, but the public, conditioned by news cycles and instant communication, demands clarity. Is it natural or artificial, harmless or dangerous? Silence is quickly filled with speculation. In the gap between evidence and explanation, imagination blooms and often grows darker than reality. Information vacuums, ambiguity is fertile ground for fear. Without official updates, rumours metastasize. Governments already know it's alien and they're hiding it. NASA detected a signal but won't admit it. The military is preparing for contact. Social media accelerates these claims, creating feedback loops where every blurry image or leaked memo is cast as proof. History has shown us that in moments of uncertainty, from UFO sightings to viral outbreaks, information vacuums are rarely benign. Scientists under siege. For the astronomers tasked with analysing 4I, the psychological burden is immense. They are under pressure from multiple fronts. Professional duty, avoid premature claims that could destroy reputations. Public pressure, calls, emails, and even harassment demanding answers. Government oversight, subtle or overt pressure to withhold, downplay, or reframe findings. In the age of transparency, secrecy is nearly impossible, but in the age of fear, truth itself becomes fragile. Why waiting? Hurts. More than knowing. Cognitive research shows that uncertainty triggers stress responses stronger than those from confirmed bad news. The brain craves resolution, even if that resolution is frightening. A definitive answer, however catastrophic, allows people to plan. Uncertainty paralyzes them, and so, when 4I's data remains unresolved, humanity enters an anxious stasis. Time itself seems to stretch. Every delay feels like evidence of concealment. Every silence becomes a signal. The weeks of uncertainty between detection and confirmation are not just a scientific interval. They are a social stress test. Each community, each institution, responds differently, revealing fractures in how humanity processes the unknown. Governments, managing panic versus managing truth. Governments tend to prioritize stability over transparency. In the face of 4I's arrival, emergency sessions convene, but press releases are carefully crafted, filled with words like monitoring, no immediate danger, and further study required. Intelligence agencies monitor not only the skies, but the internet, tracking narratives, gauging public sentiment, and neutralizing potential disinformation. Some nations may exploit the uncertainty, framing 4I as proof of their superiority in space defense, while others push for international cooperation under the banner of planetary safety. The result is a delicate balance. Too much caution risks eroding trust. Too much candor risks igniting panic. Media. Feeding the suspense. Mainstream media, constrained by credibility, will amplify official statements while quietly hinting at anomalies. Independent journalists and fringe outlets, however, thrive on ambiguity. Headlines scream, "Is 4I watching us?" or "Leak signal data suggests more than rock." News cycles evolve in waves, first the discovery, then the debate, then the silence. Each lull creates a new surge of speculation. Documentaries, podcasts, and viral videos flood digital platforms, blending fact, theory, and outright fiction. Suspense becomes commodified. The waiting period is not just endured, it is monetized. Religion and philosophy, filling the void. Faith communities and philosophical movements often step into uncertainty with certainty of their own. Some declare 4I as a sign, fulfillment of prophecy, or a cosmic warning. Others interpret it as proof of a higher order, an intelligence guiding history. New Age movements seize the moment, weaving 4I into narratives of ascension, contact, or awakening. The ambiguity itself becomes fertile soil for belief. In the absence of evidence, conviction thrives. Ordinary citizens, between wonder and fear, for ordinary people, the waiting period manifests in small personal ways. Skywatchers point telescopes, seeking glimpses of the unknown. Parents debate whether to shelter children from the news or to prepare them for change. Communities fracture between those who dismiss 4I as irrelevant and those who obsess over every update. The psychology of waiting filters down to the dinner table, the classroom, the workplace. It is not only scientists and governments who feel the strain, it is everyone. The unifying paradox. Ironically, the same uncertainty that breeds division can also inspire unity. For a brief window, humanity stares upward together, bound by the same question. What is it? That shared suspense can spark collective wonder, a recognition that despite differences of language, nation, or creed, we are all passengers on a single planet awaiting the verdict of the stars. By the time humanity reaches the midpoint of waiting, suspense inevitably transforms into strategy. Even without definitive confirmation of 4I's nature, preparation becomes unavoidable. Institutions cannot afford to wait passively. They must plan for scenarios ranging from trivial to existential. Science, the race to observe. For astronomers, preparation means mobilization. Telescope time. The world's major observatories negotiate and reallocate hours, prioritizing 4I over other projects. The James Webb Space Telescope, the Vera Rubin Observatory, and Europe's extremely large telescope all shift schedules. Data coordination. International consortia form to ensure shared analysis. One telescope alone cannot map the full story. Mission concepts. Space agencies begin dusting off old plans for rapid response interceptors, probes capable of rendezvous with an interstellar object. Engineers sketch trajectories, debating chemical versus nuclear propulsion, knowing that political approval may never come in time. The scientific response is pragmatic. Study, intercept if possible, and prepare to learn no matter the outcome. Governments, security and diplomacy. Governments view 4I through the lens of risk management. Defense briefings. Military agencies examine worst-case scenarios, from debris impact to surveillance craft disguised as comets. The possibility of 4I being artificial, however remote, demands classified war games. Diplomatic channels. Quiet conversations unfold at the United Nations, in back rooms of NATO, and within bilateral talks between rivals. The fear is not only what 4I is, but how nations might react differently to it. Cooperation or competition. Shared vigilance or secrecy and advantage. Emergency protocols. Continuity of government planning, normally reserved for nuclear war, is quietly adapted. Where would leaders shelter? How would mass panic be controlled? To governments, preparation is not only about the sky, but about the ground, the fragile societies they must keep intact. Civilians, between readiness and resignation. For ordinary people, preparation takes subtler, more personal forms. Preppers, stockpiling accelerates. Forums buzz with theories, strategies, and lists of survival essentials. Even without confirmation, the perception of risk drives behavior. Dreamers. Others respond by leaning into hope, organizing sky parties, creating art, writing speculative fiction. For them, preparation is not about defense, but about meaning-making. Everyday life. Most people, however, simply absorb the news with quiet unease. They continue their routines, but with a shadow overhead. The psychological split grows, outward normalcy, inward anticipation. The dilemma of preparedness. The paradox is this: prepare too visibly, and you risk panic. Prepare too quietly, and you risk paralysis. Humanity has never faced a visitor like 4I, and so every response becomes improvisation. For some, preparation feels like overreaction. For others, anything less feels reckless. The tension lies in the unknown. You cannot prepare rationally for what you do not yet understand. The preparations never stay hidden for long. In an interconnected world, even the smallest shift in behavior, a leaked memo, a rescheduled launch, an unusual troop movement, becomes fuel for speculation. By the time whispers of 4I reach the public, the line between official planning and rumour is nearly impossible to draw. Scientific leaks and accidental disclosures. A mission concept sketch uploaded to an internal NASA server accidentally appears in a public cache. The diagram shows an interceptor probe labelled Emergency Response Vehicle. Within hours, screenshots spread across social media. An astronomer, frustrated by government silence, gives an anonymous interview hinting at anomalous readings that don't match ordinary comets. The scientist never uses the word artificial, but the internet fills in the blanks. Amateur observers with backyard telescopes confirm unusual brightness fluctuations. Blogs and forums amplify their findings, suggesting propulsion or structural shadows. Even if science is cautious, leaks accelerate the sense that something is being hidden. Government drills and civilian perceptions. Governments quietly adapt readiness protocols. Local emergency services run continuity drills framed as generic disaster prep. Yet documents mention atmospheric anomalies and orbital events. Military satellites realign to monitor deep space more aggressively. A few hobbyist skywatchers notice the changes and speculate online. In some countries, encrypted radio traffic spikes. Observers track it and conclude, wrongly or rightly, that leaders are bracing for impact. For the average citizen, none of this is conclusive, but in the fog of waiting, every scrap of information feels like proof. Public response. Between unity and chaos. Unity. Communities organize stargazing vigils, lectures, and online forums dedicated to sharing updates. For some, preparation is not fear but collective wonder. Chaos. Panic buying surges in certain regions. Conspiracy theorists warn of global cover-ups. Scammers exploit fears, selling anti-radiation kits or fake insider reports. The duality of human response becomes obvious. One part of society leans toward meaning, another toward fear. The first whisper of Four Eyes' power. Above it all, a new undercurrent emerges. What if Four Eye does not simply pass but decides to stay? The waiting no longer feels passive. It feels like standing on a shoreline, watching a distant storm cloud and not knowing whether it will drift away or make landfall. By the time preparations seep into public awareness, the world has already crossed a threshold. Four Eye is no longer just an astronomical object. It is a mirror, reflecting back our anxieties, ambitions and divisions. If Four Eye is revealed to be more than ice and dust, if its trajectory, chemistry or emissions hint at deliberate design, humanity would be thrust into the uncharted realm of first contact. Though often imagined in science fiction, there are actual frameworks drafted by scientists, governments and international bodies for just such a possibility. The question is, would they work? The SETI post-detection protocols. For decades, the Search for Extraterrestrial Intelligence, SETI, has maintained a set of post-detection protocols. These aren't binding laws, but guidelines. They say that if a signal is detected, it must be verified by multiple independent observatories. The discovery should be announced transparently to the global community. No reply should be sent until there is broad international consultation. On paper, it is an elegant system, scientific, cautious, democratic. But critics argue that in practice, geopolitical pressures, fear of panic, and the race for prestige would fracture this careful ideal within hours of confirmation. The United Nations Office for Outer Space Affairs. The UN once floated the idea of a cosmic ambassador, someone who would lead humanity's response to contact. Though largely symbolic, it reflected a recognition that no single nation should own first contact. Still, the UN lacks enforcement power. In reality, if Four Eye emits a message or demonstrates intent, the world's most powerful nations would likely dominate the response. National security playbooks. Behind the scenes, militaries also maintain protocols. The US, Russia, China and others have classified procedures for unknown aerial phenomena and space anomalies. These protocols prioritize threat assessment. Could it attack? Could it observe? Defense readiness, satellite positioning, electronic warfare. Information control, deciding what, if anything, is released to the public. Unlike SETI's scientific openness, military playbooks lean towards secrecy. In a crisis, these opposing instincts, transparency versus control, could collide. The reality of Four Eye. If Four Eye displayed even subtle signs of intelligence, all these frameworks would be stress-tested at once. Would scientists publish anomalies immediately, or delay under government request? Would nations cooperate under the UN, or splinter into competitive factions? Would humanity keep silent or try to speak back? The truth is sobering. No plan survives first contact intact. Protocols are guides, not guarantees, and history suggests that secrecy and rivalry often overwhelm cooperation when the stakes are highest. If Four Eye were confirmed as more than rock and ice, the first few hours after such an announcement would test the strength and fragility of humanity's plans. Protocols on paper suddenly become human actions under pressure. Let's trace how it might unfold. Hour 03. The scientific announcement. A verified anomaly, radio pulse, propulsion signature or geometric structure, is confirmed by at least 3 observatories. SETI researchers, bound by their own guidelines, release a technical note to the astronomical community. Within minutes, the preprint spreads online. Journalists pick it up. By the time official press conferences are scheduled, the world is already buzzing. The tension here, SETI guidelines say, announce transparently. Government protocols say, control release. This clash happens instantly. Hour 3 to 12. The government response. National leaders convene emergency calls. Statements are drafted. Intelligence agencies demand raw data. Military analysts frame scenarios. Surveillance platform, probe, weapon. The UN attempts to coordinate messaging, but is sidelined by the great powers, the US, China, Russia, each eager to shape the narrative. Behind closed doors, diplomats argue, should we call it extraterrestrial intelligence, or something softer, like unexplained anomaly? The choice of words matters. It could be the difference between public awe and public panic. Hour 12:24. The public reaction. Mainstream media. Cautious headlines. Object 4I exhibits unexplained behavior. Social media. Chaos. Leaked images trend globally. Hashtags like Na4I signal of they are here and cover-up surge. Markets. Investors panic, fearing instability. Tech and defense stocks spike. Airlines and tourism plummet. Religion and philosophy. Statements flow in. Some see confirmation of prophecy, others a cosmic opportunity. Ordinary citizens are split. Some celebrate, some hoard supplies, some simply stare at the night sky. Our 24:48. The breaking point. By now, clarity is impossible. Competing narratives spiral. Scientists urge caution. We need more data. Politicians urge calm. No threat detected. Conspiracists scream betrayal. They're hiding the truth. The official first contact protocols, calm, cooperative, transparent, unravel under the weight of human psychology. The irony is stark. The first signal from another intelligence may not destabilize us. Our own response will. The lesson of protocols. The first contact protocols are designed to offer guidance, not control. The reality of 4I's revelation would show us that. Transparency versus secrecy will be the first battlefield. Unity versus rivalry will determine whether humanity faces the unknown together or fractured. Fear versus wonder will shape how ordinary people remember the moment as the dawn of a new era or the beginning of panic. The truth is simple and terrifying. There is no rehearsed script for contact. There is only improvisation by scientists, by leaders, and by every person alive,